Guys, in today's video we're going to be discussing about the effects of insulin. Guys, I really want to be talking about its effects on the carbohydrates and the lipids and as we know, the proteins. I want to talk about like their processes which they stimulate, and insulin is a very important hormone. And if you know insulin, then glucagon is basically the opposite. So if you know insulin, you know glucagon. So it's a double deal. I want to talk about like how does it affect it. So of course it causes it's after a meal, so it causes hypoglycemia. So it lowers your blood glucose level. I want to know that you guys know that it causes it causes protein synthesis. So it causes anabolic effect and lipogenesis. So I guess that's pretty straightforward. Now guys, let's move over here into the second column, and I want to talk about over here the more particularly effects which what does it activate and what does it inhibit. Right. So guys, straight off the back, you guys need to know this, like you just need to know the glycogenolysis. You need to know that anything lysis, it would inhibit it, and gluconeogenesis, it's going to inhibit it because gluconeogenesis increases blood glucose level. As we know, insulin is after a meal, so you want to decrease blood glucose level. The next thing I want to talk about is going to be activation. Activation is the main thing. Glycolysis, that's the main pathway, and I'm also going to be talking about the enzymes very, very shortly. So glycolysis, as we know, is both a catabolic and anabolic pathway. So we can classify it as a we can classify it as a amphibolic pathway, as it involves catabolism, and it can also be anabolic. Right now we were focusing on the anabolic to make pyruvate. The next pathway which I want to be talking about is obviously, as we know, is the uptake of glucose in the skeletal muscle and the adipose tissue. But off the bat, I want to be talking about it's going to be also increasing the it's going to also be increasing glycogenesis and the HMG shunt. Oops, sorry about this. Alright, so hexose monophosphate be inhibiting that. So that's a key. That's a very big key. Like I said, I want to focus on the glycolysis part. So which enzyme does it really focus on? So obviously over here, as we know, the main enzyme that it dephosphorates. So when I say dephosphorates, it means I'm referring to activating. So we have to focus on all of the rate limiting steps. So glucohexokinase. So hexokinase. Then the next thing would be the glucohexokinase, and the next thing would obviously be our beautiful hexokinase or glucohexokinase. Doesn't really make a difference. So glucokinase or hexokinase, you can use either one of them. It dephosphorate them. Fructose kinase stimulates that, and stimulates that by dephosphorylation, and then the pyruvate kinase. This is going to be one of the last steps from the phosphoenol pyruvate to the pyruvate. Now I want to talk a bit more about the inhibiting. So what does it inhibit? So like I said, it would inhibit enzymes of the glycolysis. So again, I'm just going to make an enter over here and just continue over here. So of course, pyruvate carboxylase, because remember, pyruvate carboxylase is going to be involved in the pathway of the pyruvate carboxylase is going to be involved in the pathway of breaking it down, right? Forming gluconeogenesis. So it's going to be involved in gluconeogenesis. So it would of course cause the inhibition of that. Another one would be the 1,6-bis phosphofructase. 1,6-bis phosphoglycerate synthase. Fructose 1,6 this phosphatase but it would cause the inhibition of that by phosphorylating it, or just what else would it cause the inhibition of? The glucose 6 phosphatase, which is, of course, it's just a mirror image of this. So stimulating glucokinase hexokinase, inhibiting glucose 6 phosphatase. Then stimulating pyruvate kinase, inhibition of the pyruvate carboxylase. Then stimulation of the phosphofructokinase 1, but then inhibition of fructose 1,6 bisphosphatase. Right, bisphosphatase, exactly. Now guys, a bit easier job now. Let's move on to the lipids. The lipids, I would say, is the easiest part. I would go over here, activation, and let's put inhibition over here. Inhibition straight off the bat, lipolysis. Like I said before, anything lysis, anything breakdown, insulin does not like it. It likes anabolytic effects. It's a major anabolytic hormone. Essentially, insulin is a major anabolytic hormone. If you get it in the exam, that's a key. Like, if you understand that, that's the basis of everything. That's the foundation. And now what's going to be the so of course activation of chlorine synthesis, cholesterol, ketone, no, not ketone bodies. Ketone bodies will inhibit it. Cholesterol fatty acid synthesis, and the fatty cholesterol, and the lipid synthesis in general, right? So it would cause the triglycerol synthesis. And now a protein would be the activation would be this, inhibition could be this. So now what could be the inhibition? Of course, proteogenesis loves that, but let's focus a bit more on what else can make proteins. On the main thing they can make is pyruvate kinase, pyruvates and pyrimidines, purines and pyrimidines. Purines, of course, required for the basis, and the is present in the phosphate backbone, present in the DNA, and of course also in the RNA. So RNA polymerase stimulate that, and transaminase, anything to break it down, would break it down. It would not allow that. So guys, this is about it. I just want to let you guys know. I hope you guys enjoyed this video. Hope to see you guys next time. Thanks for watching.